The force between two charges spaced by 3.5 times 10 to the negative fifth meters is 2.3 times 10 to the negative third. My goodness. Okay. If the value of one charge is this, what is the value of the other charge? So we got to figure out what the charge is on probably Q2 is what I'm thinking. So the first thing I'm doing is I'm writing down my givens. The first is the distance between, and I've written it in scientific notation just like they've got, and I put my units in the blue. That way you can follow along and don't get confused or not putting the blue with the black. And the next one is the force between them, and I've abbreviated that F sub E to indicate it's a force of electricity, so the electrical force, and that is measured in newtons, which is in blue, and that's the value that we put in there, the same as we copied up here. Next one's Q1, that we symbolize the charge with the symbol Q, and we've indicated 1, meaning it's the first one. It doesn't matter where they are, 1 or 2, but we've called this one number 1, and we've copied the value of that charge directly right here and labeled it coulombs, because we know that charge is in coulombs, named after the guy who did all of this work. Then the next one is K. This is a constant that Coulomb came up with. It's not written up here, it should be, but the value is here. 9 times 10 to the 9th Newton meters squared over coulombs squared, and again that's in blue. So I've got all my givens set up. The next thing I have to do is just figure out what I want to find, and that is Q2. And I'm assuming it's going to be in coulombs because I expect charge to be in coulombs, but we want to make sure our algebra shows us that's the case at the end. Then we get into our general equations. We're given this equation. This is Coulomb's life work here. The force of the electrical force is equal to his constant times the charge of 1 times the charge of 2 divided by the distance between them squared. Now we're just doing some algebra to get the variable that we want by itself on one side of the equal sign. So that's Q2. So Q2 is going to be right here. Excuse me. So I'm going to do the basic algebra. I'm going to multiply both sides by d squared. The d squared over here will drop out, and we get the d squared shows up on this other side. I'll notice it's in the numerator here. The next step, I want to get this k and this q1 by itself. So I just divide both sides by k q1. That drops out on this side, and we find it over here in the denominator, k q1. Then the next step is you plug and chug the values, and I realize that this paper is far too small to do this problem neatly. For that I apologize. So I've jumped down to a separate sheet of paper. And I've written the equation here, just plugging in the values. I'm just simply replacing this with this down here, and notice I am keeping the units as well. Then we have this one here. This is a very common mistake. Don't drop your squared. So the d squared is actually this value squared, and don't drop it on your units either. It's the meters is squared now. Then I've plugged in my q1 and my q2, excuse me, my q1 and my k, and now I've got to figure out how to type this into my calculator. If these numbers were just 4, 7, 9, and 3, we could all do it on a calculator easily, but we've used scientific notation. So I have my calculator here. Let me turn it on. It hopefully has batteries. There it is. And here is, I've done it in 2 steps. The first step is I want to replace my times 10 to the with EE, because EE really stands for times 10 to the. So I'm just rewritten the entire equation with these to try to help break down what we're going to do. Notice I kept my squared, and at this point I dropped my units just so we can work on the calculator entry. Now that I want to do these, the way I would do this on a calculator is I do it in sections. This one has an exponent, so I do this one first. And you'll notice that comes down here. Here's all the commands that I'm typing into my calculator, but go through it like you're reading a story. So I'm not typing anything here, I just know that whatever I hit enter to is going to equal Q2. So the first keystroke is 3.5 EE negative 5. That's this value. Then I raise it using my caret to the 2, and I hit enter. Now on the calculator, it's got this value in its head. If I go ahead and hit multiply, it's now multiplying by the next thing I type in, which is simply this value, 2.3 EE negative 3. Then I can divide it by 6.7 EE negative 12. Here I've gone here to here. Now I've dropped down to do this function. And I always get nervous when I do multiple things at once, so I'm going to go ahead and I hit the equal sign to get the value of these 3 in the computer's mind. And then I'm going to divide it one more time by this 9, EE9, and then I hit my equals button. And at that point, the answer is what should be on the screen. Let's roll the dice and see how we do. Okay. 3.5. It's hard. EE, negative 5 raised to the 2 equals that really, really small number times 2.3 E negative 3. Am I doing this right? Okay, I don't know. Divided by 6.7 7e negative 12 equals divided by, where am I at over here? Where am I at? I'm at 9EE9. 9EE9 equals, did anybody else get that answer? 4.67? Oh, you can't see it? Oh, here's what I got. I got 4.67 times 10, or EE, negative 11. Is that what everybody got? All right. Okay.